This is a flip video about Lewis structures and ions. So let's remember that an ion is a substance with a charge. And let's take a look at our first structure here. We've got NH4 and NH4 with a positive 1 charge, which is ammonium. Okay, so the first thing you want to do is you want to ask yourself, what does this charge mean? Remember, when I have a positive or negative, it means I either lost or gained electrons. Specifically, a positive charge means I lost, and I've got a positive 1, I lost 1 electron. When Miss Brazian's positive, she lost weight, right? So I'm going to do these structures the exact same way I've been doing them in the previous videos, but I'm just going to take into consideration the loss of 1 electron. So my first step is to calculate the total valence electrons. Remember, I've got 1 nitrogen, and each nitrogen has 5 valence electrons. It's in the 5th column for a total of 5. And I have 4 hydrogen atoms, and each hydrogen has 1 valence electron because it's in the 1st column for a total of 4. Add them together and I get 9 valence electrons. But don't forget, you lost 1. So I'm going to subtract 1 valence electron and I get a new total of 8 valence electrons. So let's draw the Lewis dot structure for this. Again, you want to make sure that you pick the first atom as your center, except for hydrogen. So nitrogen's my center, and I want to bond everything to my center. I get a total of 8 valence electrons. I have a hydrogen here. I have 4 hydrogens, hydrogen, hydrogen, hydrogen. Attach them to the bonding sites. Remember, start with a bonding pair. Bonding, bonding. 2 electrons make 1 bond. So I've got 2, 4, 6, 8. Nitrogen's happy. And remember, hydrogen follows the duet rule. So 2 will do for hydrogen. So 1, 2 for hydrogen, 1, 2 for hydrogen, 1, 2, 1, 2. Hydrogen's happy. And again, I said I needed a total of 8, and I fulfilled 8 valence electrons. The last thing you want to do is to represent that this substance had a charge on it. So what you have to do is anytime you are doing the Lewis dot structure of an ion, the entire structure is put in brackets and the charge goes on the outside. Again, I copy the same charge that was on the ion itself. Charge is on the outside, not the inside. Okay, let's do one last example. We'll do a popular one. We'll do nitrate, NO3 minus, polyatomic ion. So first ask yourself, what does that 1 minus mean? It means gain 1 electron. Next, do your total valence count. Nitrogen, there's 1 of them, 5 valence electrons for a total of 5. There's 3 oxygens, each come with 6 valence electrons for a total of 18. Add them together and I get 23 valence electrons. But this time I gained 1. So when I gain 1, I add 1 valence electron, seen here, for a total of 24. That's my new total. Let's go ahead and draw this structure out. So I put nitrogen in the center. First atom goes in the center. It's actually the least electronegative goes in the center, which is usually the first atom. And I have 3 oxygens bonded. Put them on the 3 bonding sites, wherever there's a bonding site, so 1, 2, 3, and bond them singly first. Pair of electrons, bond. You can use the sticks as well. So I've got 2, 4, 6. I get to use 24. I'm going to make nitrogen happy with 8, 2, 4, 6, 8. Nitrogen is happy. And then I'm going to go ahead and make all my oxygens happy. So I already used 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Uh-oh. I've used 24 electrons. 8 around the center. 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. And this oxygen is not happy. So I'm going to need a double bond somewhere. All right, let's try this again. Nitrogen, oxygen, oxygen, oxygen. So let's try 1 double bond here and my single bonds here. Nitrogen's happy because it has its 8. 1, 2, 3, 4, 5, 6, 7, 8. Now this oxygen doesn't need as many because it already has 1, 2, 3, 4, 5, 6, 7, 8. So I've used up 8 here, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Again, I needed 24 valence electrons. So this really redrawn is going to look like this. Nitrogen in the center, singly bond to an oxygen, singly bond to an oxygen down here, doubly bonded to the oxygen here. Don't forget to fill in all of your, sprinkle around your other electrons. 2, 4, 6, 8. Don't forget all of these to make them happy. 8 is great. 8 will make everything happy. I don't need any more on the nitrogen. 2, 4, 6, 8. Now remember, this was a charged, right, compound here. We have NO3 minus. Anytime you're drawing the structure of an ion, it goes in brackets and the charge goes on the outside. Sneak that charge in right there. Minus. Don't forget charge and brackets, and they're only used when you're dealing with a Lewis structure that is an ion. That's the end of the video.